Okay, this next example is a little bit harder. It's not harder because of the calculus, but because of the trigonometric functions that we're dealing with. So here the question says, determine the position and nature of stationary points when x is between 0 and 2 pi inclusive for this function, and hence sketch on this interval. Okay, so number one, they're giving you an interval, and they always will. If they're giving you a trigonometric function, they'll always ask you to sketch over an interval and also determine, stationary points over an interval. Here, the wording seems a little bit different, but they're asking for the exact same thing. When they say position, what they mean is just find where the stationary points are. And when they say nature, they don't mean like nature as in trees. They mean nature as in classify the type of stationary point that you're dealing with. So really they're asking the same thing as the earlier example. The function's a little bit different though. So first thing we're going to do is find the derivative. Here what you need to know is the derivative of exponential functions. So here the derivative of e to the x is e to the x. So the derivative of e to the power of sine x is going to be e to the power of sine x multiplied by the derivative of the inside function. The derivative of sine x is just cosine x. So that's our derivative. Now here I want us to notice something very important, and this comes up all the time. In fact, just write it down in another color. E to the power of x is bigger than 0 for all values of x, okay? As in the exponential function base e, the exponential function base e is always positive. And because that's always positive, e to the power of sine x will also always be positive. And that's not always obvious. As you do more and more math, these things will become more and more obvious, but you want to be on the lookout for things that are always positive or non-negative. So this is always positive. This thing might change sign. It will change sign, okay? So we need to worry about this thing. But before that, let's just find the stationary points. We're going to find the stationary points by setting the derivative equal to 0. So at stationary points, f prime of x is equal to 0. So therefore, we can say, well, 0 is equal to e to the power of sine x times cosine x. We know that e to the power of sine x is positive, so it's never going to be equal to 0. That means that cosine x is 0, and that means that x is either equal to, so here you have to kind of think. So think about these angles between 0 and 2 pi. That's one full revolution. When is cosine x equal to 0? It's equal to 0 when x is pi over 2. Or 3 pi over 2. These are the x coordinates of our stationary points. Let's go ahead and just find the y coordinates as well. We might as well. So when x is pi over 2, what are the y values? So the y value is going to be e to the power of sine of pi over 2. Okay, so I'm plugging these back into the original function here. Sine of pi over 2 is 1. And so what we get is just e. And in the same way, x equals 3 pi over 2. When x is 3 pi over 2, y is going to be e to the power of sine of 3 pi over 2. Sine of 3 pi over 2 is negative 1. And so what we're left with is e to the power of negative 1. That's the same as 1 over e. Okay, so we have two stationary points. And these are the two stationary points, pi over 2e and 3 pi over 2 comma 1 over e. We're going to have to determine their nature, classify them, and we'll use a sign chart to do that. Now when you make your sign chart, a common mistake I see is like people are like making their sign chart from negative infinity to positive infinity. Here they only want you to sketch and only determine stationary points in this interval. So your sign chart can have a minimum and maximum value. The minimum value is 0. The maximum value is 2 pi for x. Okay, and then what you can do is you can kind of ignore all the values to the left of 0, ignore all the values to the right of 2 pi, and that's fine. Okay, at pi over 2, we know that the derivative is 0. At 3 pi over 2, we know the derivative is 0. Just mark that in. So here it's 0, here it's 0. What we need to do is, number 1, test the value between 0 and pi over 2. Then test the value between pi over 2 and 3 pi over 2. And then between 3 pi over 2 and 2 pi. Okay, so again, we're testing these values in the derivative. So please be careful, not in the original function. We're testing values in here. So between 0 to pi over 2, we can choose maybe a quarter of a pi, which is in between. If you plug in anything into this, it's always going to be positive, okay, because this is always positive. So if we plug in a quarter of a pi into cosine of x, remember a quarter of a pi is in first quadrant. In the first quadrant, cosine of an angle is positive, so we're going to get a positive value. And then between pi over 2 and 3 pi over 2, we can just choose pi. If we plug in pi into here, cosine of pi is going to be -1, so that'll be negative. And then between 3 pi over 2 and 2 pi, we're in quadrant 4. Quadrant 4 cosine is positive. Okay, so that's what our sign chart looks like. This means that our function is increasing, decreasing, then increasing. Therefore, we can say that, our first coordinate pair, pi over 2 comma e, is a local max. It's a local max because if we look around pi over 2, the function is increasing, then decreasing. And so it's got to be a local max. And then if we look at the next coordinate, 3 pi over 2 comma 1 over e, we know that that is a local min. Okay, and the reason is, again, because at 3 pi over 2, function is decreasing to the left, increasing to the right. Okay, and that's it. So we've found and we've classified the stationary points. What I'm going to do is I'll pause for a moment if you haven't jotted things down and copy it into your notebook. What I'm going to do next is move some of this stuff down and then try and sketch. Okay, so the next thing I want to do is sketch. Okay, so I've copied down the essential pieces of information, the sign chart here, as well as what my local max and mins are, and I'm going to use that to help us make a sketch. Again, try and make it so that your x scale lines up with the x scale of your sign chart. That'll just make things easier. And then label in all your x coordinates of the stationary point. So put in pi over 2, 3 pi over 2. Do that first. We know at pi over 2, the y value is e. Again, a lot of people worry about how to plot e. You just need to plot it carefully enough. Like, it doesn't need to be perfect. It's not gonna be. So just do it so it's roughly correct on your y scale. Okay, so here's my y scale. Move that over a bit. And so I've chosen this height to be roughly e. Okay, just roughly. Doesn't need to be perfect. And then at 3 pi over 2, we know the y value is 1 over e. Again, you don't need a perfect, like, let's say e is about 3. Then 1 over 3 is a third. Okay, and like you can just do rough approximations for when you're plotting, but please label it. Because it's an exact value, I think it's nice to label it. Okay, so I'm going to label both of those points. Now, the other points that I might want are the boundary points, so at 0 and at 2 pi. So if we go back to the original function, when x is 0, sine of 0 is 0, and e to the power of 0 will be 1. And sine of 2 pi is also 0. E to the power of 0 is 1. So actually what we're going to have is when x is 0 or 2 pi, doesn't matter either, the y value is going to be 1. Okay, and you can just plug it into the original function to confirm. You just have to be careful that you plot 1 in roughly the correct spot. Okay, so 1 is going to be somewhere in between 1 over e and e. Okay, roughly, maybe there. Okay, and so here you go, 2 pi comma 1, and then 0 comma 1. Okay, so now that we have the endpoints as well as the stationary points graphed, we're just going to use our sign chart up here to graph the rest. So the function is going to be increasing from 0 to pi over 2, maybe something like that. And then from 0 or pi over 2 to 3 pi over 2, it's going to be decreasing. And then maybe let's just make that a little bit nicer, so something like that. And then from pi over 2 to 3 pi over 2, it's decreasing, and then it's going to be increasing after 3 pi over 2. Now, I know we don't really have exact, like, we haven't really developed a more exact way of graphing. Like, how it increases is not really relevant. Like, does it do this or this? For today, it's fine. You can have it decreasing however you want, so long as the intervals of increase and decrease are correct and the stationary points are, correct, like their local maximums or minimums. And as we do more and more curve sketching, you'll get a better and better, more precise way of sketching. For now, though, this is perfectly fine. The other thing is you can always use your GDC to confirm your sketches, although I would try and do as much of this without a GDC as possible. Okay, last thing we're going to do is I'm going to give you some tips. This concept comes up over and over again, functions that are non-negative, so functions that are either positive or zero, and you need to be able to recognize them. Examples of that were here, I recognized that e to the power of sine x was positive, and here, where was it? Here, I recognized that x squared plus 1 was always positive. See, here are some functions that... Here are some functions that are always positive, or non-negative, I should say. X squared is always bigger than or equal to 0 for all x. Now, it doesn't just have to be an x. For example, if I had sine x all squared, that's also bigger than or equal to 0 for all x. Okay, so just watch out for squares. Squares, by definition, are bigger than or equal to 0. Absolute value of x, okay? So absolute value of x is bigger than or equal to 0 for all x, and for example, if that was instead absolute value of sine x, that's still true, okay? Quadratics. If you have a quadratic in this form, and if the a value is positive, meaning the function opens up, and the discriminant is negative, meaning it has no real roots, then this quadratic will always be positive, okay? And so be on the lookout for quadratics that are always positive. Lastly, exponential functions, they're always positive. As long as you have a valid base, they're always positive. 2 to the power of x, always positive. E to the power of x, always positive. 1/2 to the power of x, always positive. Okay, the reason it's important to be on the lookout for these is because you almost have to, when you're making your sign charts and stuff, like, you don't have to worry about these non-negative functions. They're always going to be positive or maybe 0 at the edge case. And so you don't have to concern yourself with them. You want to be concerning yourself with functions that change sign from positive to negative. Okay, so hopefully that works or that helps. And today, hopefully you learned a little bit about stationary points, classifying them, but also a little bit about curve sketching, how to sketch curves that are unfamiliar to you. The goal is to be able to sketch curves that are unfamiliar to using calculus, using sign charts. And hopefully today you made some progress in that. Okay, have a good rest of your day. Stay safe.